The sound should be proportionate. May I next invite Mr. Kapil Maheshwari, Leader, Renewable Energy and Green Hydrogen Ecosystem Development and President, Reliance Industries Limited. Next we have Mr. Sandeep Kashyap, COO, ACME. May I next invite Dr. R.K. Malhotra, President, Hydrogen Association of India. We'd also be joined by Professor Rajneesh Kumar. He is from BITS Pilani. He'll be joining us slightly late. So we have all the speakers for this session. First up, it would be Dr. R.K. Malhotra, President, Hydrogen Association of India, who would be addressing the gathering. So I'd please request Mr. Malhotra to come up.
A very good afternoon to all the co-panelists and the senior people, Mr. Rajdan, I can see Mr. Deepak Gupta and Pranav Mehtaji. And thanks, Mr. Mehta, for giving this opportunity to be here. In fact, he already mentioned that in the year around 2010, we had founded the Hydrogen Association, and he was also very active, one of the founders along with us when I was at Indian Oil. And at that time, we had set up the hydrogen dispensing station also. All of you would be wondering that 12 years ago, we did that, and all those years, Indian Oil R&D had been doing some of the work on HCNG and other things, etc., etc. And now for last 2-3 years, everybody has started talking about hydrogen. And I, when we started hydrogen, formed the Hydrogen Association and started the activities, many of my colleagues on the board also said that this is far off. Why are you spending time on this? I said the company has to be prepared for future. So maybe that is now when my successors have been doing work over there. But we have continued with this association and doing annual conferences on hydrogen and fuel cells, which is providing sufficient knowledge base to the industry over these years. The subject of today's presentation or this session was manufacturing, storage and transportation and demand side scenario and market for green hydrogen. So I would like to share some of my thoughts regarding these kind of things. All of us know that hydrogen is produced in the refineries, and we in the refineries are the largest producers and consumers of hydrogen. We have been doing it for decades. We have been producing it from oil or natural gas, and that's perhaps one of the easiest route for the refineries. So we know how to play with hydrogen, how to use hydrogen, how to handle hydrogen in the refineries and in the oil sector, particularly which I belong to. Having said that, when you look at the various opportunities like green hydrogen, where the solar costs have come down in the recent time from 17 rupees to 2 rupees or maybe under that, that's a great opportunity for India to produce green hydrogen and also green ammonia, which we have been talking about in this country. But the cost of hydrogen, green hydrogen at this point of time, which is estimated to be around $7 per kg. Mr. Mehta did mention about $5 a kg, and Sunita Satyapal was putting US target as $2. Mr. Ambani of Reliance, Mr. Maheshwari will elaborate more on that possibly. He has set a target for $1 per kg. It is a very ambitious target, and I wish that happens by 2030. I think he has put that target for himself. 2030, yeah. So if that happens, that would be a revolution. $1 per kg of hydrogen will provide enough opportunities for various sectors to use it, and that will help the country also in a big way, where our energy dependence from oil and gas sector will reduce and import dependence will come down. But in the meanwhile, we have also been looking at that during the interim period, what should we be doing? Should we wait for that $7 to come down to $1 per kg and then think of creating the infrastructure for hydrogen in this country? Our views from which I have been propagating on this subject is that let us not wait for that to happen. Let us not be talking about green hydrogen economy or green hydrogen mission. Let us talk about hydrogen mission or hydrogen economy. Because if we do that, maybe whatever source you can get hydrogen, whether you can get it from coal, whether you can get it from biomass, there are plenty of opportunities for getting hydrogen produced from various sources, whether it is gray, brown, blue. Let us not talk. Hydrogen is colorless. Let us not wait for this to be purely green to be used. And let us create the infrastructure, because creation of infrastructure will take time. It is not going to happen overnight. You know, when I talk to some people, they say that even the electrolyzer supply, you know, there are no electrolyzers to be which are available for next 2-3 years, even if people want to buy that in the international market today. So if that is the scenario, this is going to happen in time to come, that when you have green hydrogen costs coming down, Mr. Ambani's mission or Sunita Satyapal, $2 per kg. If that happens, we should not be creating infrastructure at that time. So infrastructure for storage, transportation, pipeline creation, this is the gas infrastructure or hydrogen infrastructure creation will take time. So let us start working on that. And that will happen only if there is a utilization of that infrastructure. And that utilization can happen if we start using any color of hydrogen at this point of time, and slowly transit to green hydrogen when it is cost effective and people want to voluntarily use it. Now, coming on to the demand market, you know, you can mandate it that refineries must use 10%, 20%, 30% of hydrogen. And the public sector companies will use it if it is mandated. But the cost of fuel will go up, whether it is absorbed by them or not. But the cost of fuel is dependent on the cost of hydrogen which they consume. And in fertilizer sector, which people talk that we must mandate some use of hydrogen, green hydrogen to be used in fertilizer sector, where already it is subsidized. So the subsidies will have to be borne by the government. The government, on the other hand, should give PLI incentives for creation of all kind of infrastructure for hydrogen, so that we usher in the hydrogen economy fast. We must invest on R&D. We must invest on improving the efficiency through R&D of the electrolyzers. We must create infrastructure for setting up the domestic manufacturing of the various equipments, whether it is the electrolyzers or compressors or storage systems, type 4 cylinders, or tube trailers for transporting hydrogen from one place to another, whether it is gaseous hydrogen or liquid hydrogen or whatever we decide to. And in the interim, we can also, if we have surplus hydrogen, people say where to use it. We can always blend it with natural gas. We at Indian Oil had done a lot of work. My colleague, Mr. Alok Sharma, can elaborate further on that, who was with me at Indian Oil, and we had done a lot of work on HCNG. In fact, he had developed a single-step reforming process also, that you can blend up to 18% of hydrogen in CNG in any case, or natural gas pipelines. You can pump it and it can be used along with natural gas. So I think there are opportunities in the interim to be used. We can use hydrogen IC engines. In IC engines also you can use neat hydrogen, and which will be competitive with diesel, and no pollution, etc. The incentives of those kind of things will also accrue. So I think we also need to look at solar thermal kind of things, And when we are talking about electrolyzers at such large quantities of green hydrogen requirements, we have to also look at water requirements. Where do we get that water? What quantities of water will be required, where it will come, how much, whether we can use sea water, or whether those kind of technologies need to be developed. And we should not be looking at only, the EVs, or I always feel that electric vehicles hype which has happened in this country could be all right for city buses or electric trains. I think it was mentioned in the previous session also by Mr. Gupta. But we must use the hydrogen for heavy-duty trucks, which was also very rightly mentioned. And that where we can start with IC engines also, without waiting for the fuel cell cost to come down. So with these, some of my thoughts, I will stop here. And I will excuse myself, as I have to go to Gurgaon and I have another meeting at 7 o'clock, and I think it will take me 2 hours at this peak hour. So thank you very much, Mr. Mehtaji, for inviting me and giving the opportunity to share some of my thoughts. our Hydrogen Association will be conducting a international conference from 4th to 6th of December at New Delhi Lalit Hotel. So we'll be very happy if all of you could make it, and we can have more deliberations during that conference where several experts would also be coming. Thank you so much.
Thanks a lot, Mr. Malhotra, for your enriching thoughts. Next up, we invite Mr. Srivatsan Iyer, Global CEO, Euro Future Energies.
Thank you, and thank you for the invitation to address this group. It's always dangerous to come in the second panel discussion because I think everything that needs to be said would probably already have been said by now. So it's very hard to really add any new insights or perspectives in the world of green hydrogen. And not just at today's conference, but especially, I'd say, over the last year or two, when there's been so much discussed and debated about green hydrogen. So I'll keep my comments fairly brief and perhaps just address three issues, not to say that the others are not important, but really three issues that I tend to think of green hydrogen as being the ones that need to be addressed first. The first is why. Why green hydrogen? And let's take a look at it from the perspective of India alone, even though I'd say the entire world has the same problem. Our NDC goals at COP26 were to go net zero by 2070, but to reduce our carbon intensity by about 45% relative to 2005. And we keep thinking of renewable energy as a solution. Say, let's build more solar, let's build more wind, et cetera, and the whole host of issues associated with that. But let's put into perspective. Electricity generation is only about 20% of the energy matrix of the world and of India as well. So about 80% of the greenhouse gas emissions comes from energy usage of other forms. We spend so much time talking about renewable energy and building capacity and making sure it's 50% of the domestic electricity generation. To get to any meaningful decarbonization, we need to address the 80% as well. And I think that's one of the reasons green hydrogen is starting to come to the forefront, because green hydrogen offers the opportunity to go after energy as a whole and the energy matrix that's not necessarily touched by electricity. Even though I look at green hydrogen almost as a way to monetize green electrons. But we've heard a lot of speakers talk about how flexible hydrogen is. It can substitute diesel in long-distance mobility, and I think the technology already exists, whether it's through co-feed with diesel into internal combustion engines, whether it's through feeding hydrogen alone, or whether it's through fuel cells. Hydrogen can be burnt along with LPG or LNG today, or instead of natural gas or LPG. So in terms of industrial heating, which constitutes probably one of the largest consumers of energy in the world today, and one of the largest sources of greenhouse gases, green hydrogen has a role to play. We can talk about green hydrogen as a source of storage and dispensation later. And so that's why I think there's so much interest now, is because you can address the core issue of decarbonization and take a look at something that can be produced sustainably, provided it's green hydrogen. So that's, I guess, the first point I wanted to make as to why green hydrogen is relevant and why we should all give a little more thought to it. The second point is economics. Now, I think, again, there's been a lot of debate. Is it $4 a kg, $5 a kg, $7 a kg? It really doesn't matter. It's somewhere in that range. I think in the US, with the Inflation Reduction Act, with the benefits and subsidies, the estimate is to be closer to $1 a kg, which is actually now reaching the SMR cost in the US at the current price of natural gas, which is somewhere around the $5, $6 a million BTU. So with the right amount of support, green hydrogen can be economically viable. You're not talking about technology anymore, technically viable. So what do you have to do to make sure that you don't have to constantly provide subsidies? We heard a previous speaker talk about, look, this cannot be a blank check indefinitely. At some point, green hydrogen has to stand on its own 2 feet. And we heard about, not just Reliance, but multiple organizations that have a target of getting down to $1 a kg. I have no doubt that that can happen. Is the roadmap clear? Not entirely clear. But renewable energy is roughly 50% the cost of green hydrogen. And then you've got everything else, which is the capex and the other opex parts of running an electrolyzer. So the first start has to be, how do I make renewable energy cheaper? And second is, how do I work on the efficiency of the electrolyzer, the utilization factor, the capex, and whatever small opex that goes with it. And for those who think that that's not possible, all we need to do is to rewind back 15 years when solar energy was, tariffs were, I don't know what it was in India, probably 20 rupees a unit, 25 rupees a unit. But I live in the US and I come from the oil industry till I saw the light. Solar was always a curiosity. And the oil industry was never felt threatened by solar. It said, look, the economics just don't work. And today, even in the US, solar energy on a full cost basis is the lowest cost of new generation in the US. It actually outcompetes even new natural gas plants, and at some point it could even outcompete existing natural gas plants in terms of economics. And all this over a period of 2 decades. So for us to have partial amnesia and say, look, it happened in solar but cannot happen in hydrogen, I think we need to have faith that once there's economic incentives and there's technological incentives, that will happen. And the last point I want to leave you with is manufacturing. We talk a lot about manufacturing, and I think there's a lot of talk about transportation and storage. Again, as I said, I come from the oil industry where we always thought bigger is better. You build a bigger refinery or a bigger petrochemical plant. I firmly believe we need to get out of that mindset and think of hydrogen as a distributed manufacturing value chain. In other words, you generate hydrogen where you need it, don't generate it in mega scale plants and then try and move it around the world. Now, there's very creative ways of doing it to convert it to green ammonia and move ammonia in ships, et cetera, et cetera. And I'm sure that'll play a role. But take a country like India, I think it's far more practical to say, why do you want to move a molecule, move the green electrons, and produce hydrogen where it needs to be? Because the scale benefits of green hydrogen from electrolysis are just not the same as the scale benefits of creating large-scale refineries, for example. So you're not losing much in terms of economies by building small distributed units, but in terms of saving the cost and the technical complexity of actually moving hydrogen, it's a big change. So again, these are 3 points I wanted to leave you with. I'm sure the other panelists are going to have really useful insights to share with all of you. Thank you.
Thank you, Mr. Iyer. At the onset, you issued a disclaimer. What more can you add? You did add a lot to the conversation. Thank you. In the meanwhile, we've been joined by Professor Rajneesh Kumar. He's from BITS Pilani. But right now, let's have a huge round of applause for him for joining us here on the dais. And our next speaker right now is Mr. Sandeep Kashyap, CEO, ACME Group. I'd request him to please come up and share his thoughts with us.
Good afternoon, and thank you very much, NSFI, for inviting me to this session. A lot has been said on green hydrogen since morning, I would say, since afternoon. And I would like to touch upon ACME's journey, what we have done so far till now in the green hydrogen space or the hydrogen space. Well, ACME started working on the hydrogen path way back in 2006, 2007, when we were supplying power equipments to the telecommunication sector. And that was the time we worked with companies in Canada and US for introduction of hydrogen fuel cells to power telecom sites. That time we were sourcing hydrogen from chloroalkali plants. So there were 2 challenges that time we faced. The first challenge was 1 cylinder of hydrogen used to be around 65 kg. And that cylinder of hydrogen used to carry only 500 grams of gas. So you are not even sure whether you're getting a filled cylinder or an empty cylinder. Biggest issue. And the transportation cost. And the second issue was in 2008, when Lehman Brothers happened, the market crashed. The whole business model collapsed because of the gas price going up and therefore the hydrogen price going up. And that was the time we realized if we have to be in this business, we have to first fix the hydrogen availability and the price rather than working on fuel cells and other equipments which are totally dependent on the hydrogen price. In 2011, we came into solar business. We set up our first plant. By 2017, we were the third largest globally in solar as a solar developer. In 2017, we could reach to a price level of 2 rupees 44 paisa per unit. And that was the time we realized now at these price levels, we can really work on hydrogen production from solar side of the business. In 2019, while we were looking at options, we also realized that there is no green hydrogen plant available and there is nothing which is available as a reference. Being a technology-driven company, we took a step of investing over 100 crores as a R&D project. And we set up world's first fully integrated green hydrogen and green ammonia project in Bikaner, which is operational since December 2021. And this project has really helped us understand the whole dynamics of various components, their integration, and what are the variations or what are the specifications which are really required to really integrate the whole renewable energy in the production of green hydrogen and green ammonia. With those learnings, which are very, very valuable to us, we announced a very large-scale investment in Oman, which is a 1.2 million metric ton per year of green hydrogen, green ammonia plant, with an investment of almost $6.5 billion US. And I'm happy to share that, it's in public domain, that the whole output of the plant is completely sold out for the next 20 years. That gave us confidence to further work on this, and then we have signed up now 2 MOUs with 2 state governments in India, one in Tamil Nadu and one in Karnataka, for similar size projects, 1.2 million metric ton per year of green hydrogen, green ammonia. And these plants are initially going to be, for the complete export purpose. Very happy to understand that Government of India started working on green hydrogen mission after the announcement of Honorable Prime Minister. Phase 1 of the mission is already out by MOP, and we expect, in terms of creating demand within the country, there are certain mandates which are going to be there, which are in the process, and we believe that in the next couple of months, we will have those mandates be out in order to use or consume green hydrogen and green ammonia. Practically what we believe, although we are talking a lot on the green hydrogen side of the story, we believe the first thing which will happen on ground is not green hydrogen, it is green ammonia which will happen. It is very easy to transport. It is being transported for decades globally. And India consumes around 2.5 to 2.8 million metric ton of green ammonia, gray ammonia every year, and we are a net importer. So that is the first lowest hanging fruit we believe in this field. And then, as rightly mentioned, green hydrogen production versus transport, if we see, in places like industries like steel or cement or probably refineries, it is always good to produce green hydrogen, or even gray hydrogen is being produced at the point of consumption, not being transported even today. So hydrogen being the lightest molecule, it is very complex to transport, and therefore it is preferred wherever you want to have the consumption, there and then you transport the electrons and produce green hydrogen or gray hydrogen as is being produced today. There are a lot of myths around the green hydrogen price being very high. And we take references of studies being conducted in Europe, US, some other countries. We need to understand when it is green, the cost is going to be dependent largely on the cost of the renewable energy and the green hydrogen cost is going to be the lowest in the countries where the renewable energy cost is going to be the lowest. Unfortunately, Europe is not the place where green energy or renewable energy is the cheapest. So, the countries like Oman, Middle East, like Saudi, Egypt, Chile, India, Australia, these are the countries where if we produce green hydrogen, the cost of the hydrogen is going to be the lowest. And these are the places which can play a big role in terms of becoming the green hydrogen hubs for the world. In India also, if you see, if we run a bid for, let's say, solar power in Rajasthan versus in Bihar, the tariff is going to be definitely lower in Rajasthan because the solar installation is lower. And therefore, if the power produced in Rajasthan is used for producing green hydrogen, that is going to be the cheapest green hydrogen production in a particular area. And based on our learning today with our Bikaner plant, in India, we are already there with the set of technology which is available. Anywhere between $2.5 to $3 per kg, we are even producing today. Right. Now, the matter is, how do we take it to $1? What is going to play the major role? I think there are three major components which are going to be playing the major role in this. The first and foremost is low-cost financing. Currently, our debt rates are anywhere between 8.5% to 9%. And if we are able to secure dollar loans at much lower costs, then the cost is going to drastically reduce. For example, today, the average cost of solar power is anywhere between 2 rupees 50 paisa per unit. And if the same power is being produced, considering a debt rate of, let's say, 4% vis-a-vis 8.5%, I believe we'll be less than 2 rupees, and therefore there'll be reduction of cost of manufacturing in terms of green hydrogen. The second is, there is a lot of work which is happening on the electrolyzer technology, and we will see the same curve what we have seen in solar. In 2011, the tariffs were 15 rupees. 2017, within a span of only 6 years, we reached the tariff levels of 2 rupees 44 paisa. And in 2018-19, we could see some bids even at 2 rupees. So wherever we have technology, we will be able to see drastic cost reduction with the efforts being made on the R&D, the investments being done on the R&D side, and we believe that is going to be making a major role. Third is going to be solar efficiencies itself. There is a lot of R&D which is happening on the solar side of the business. So combine everything, I believe, coming to $1, I'm not sure, but or $1.5 or $1.75, but we will definitely be in that range. So this is something which I thought it'll be good for me to share with you, and I'll be happy to answer any questions either personally or otherwise. Thank you so much.
Thank you, sir, for your insights. Next up, we have Mr. Alok Sharma, Executive Director and Head, Center for High Technology, Ministry of Petroleum and Natural Gas. He'll be sharing a presentation with us as well.
Thank you, ma'am. Shri Mehta, Shri Rajdan, my fellow panelists, and ladies and gentlemen, very good afternoon to you all. Well, as Dr. Malhotra told that basically I belong to Indian Oil Corporation. I am on deputation to Ministry of Petroleum. And it was way back in 2005 when we started and we set up the first hydrogen station at Indian Oil. A lot of apprehensions were there that why you are going in this direction and why you are setting up a hydrogen station here. But I think I am very happy that after 17 years, we are seeing that hydrogen is now a reality here also. See, we started with HCNG, so we were blending hydrogen in CNG that time, and we did a lot of study, and we could come out with a up to 18% of hydrogen in CNG is okay to be blended and can be used in the existing engines of CNG. I think that we also did a big project in Rajghat bus depot on the same, and we tried it in the buses, and that was also a very successful project. Now, coming to this hydrogen manufacturing, storage, and transportation side, well, as far as hydrogen is concerned, you can see that there are various pathways. Steam methane reforming, of course, is well developed. Then electrolysis, of course, is well developed. Methanol reforming, a lot of work has been going on across the world. And then photochemical water splitting is also one of the area, but I think it will take some time, but that is also one of the area which is green source of production of hydrogen. Then there is coal gasification, of course not green, but I think that need to be targeted, as Dr. Malhotra told, that we need to work on hydrogen economy rather than focusing more on green hydrogen at this stage, for India especially. And then biomass gasification, of course, is a green route for production of hydrogen. See, as far as across the world, as you can see in this slide, that a lot of European countries are going through the blue hydrogen route also parallelly. You can see the European Union, they are also targeting blue plus green. Germany, France, United Kingdom, of course, they are all trying to mandate that blue hydrogen from gray refineries with CCUS and other can be considered as green also. So there is a thought going on across this. As far as Japan is concerned, they are totally focusing on transport. They are using blue hydrogen, and the hydrogen also is coming from, they are also trying to bring hydrogen from Australia through cryogenic route. There are already projects on where hydrogen will be coming from Australia through cryogenic, like tankers and other things. Of course, Australia, of course, like blue and green again. See, as far as hydrogen policy levers are concerned, so as told by my previous panelist also, that the first phase was launched and a lot of incentives have been given in this. The second phase, second phase of the policy is likely to be announced soon, and GSCOs will be roughly by up to 2025, it will be about 2 to 5%. It's not clear right now, but there are thoughts going on across this. And by 2030, there is a very ambitious target. I don't know whether it will come like 50% or something, but there are ambitious targets to go up to 50% by 2030. Then, of course, 5 million tons of green hydrogen by 2030. Then a lot of electrolyzers and other things are being talked about. See, as far as green hydrogen is concerned, I will say that apart from the electrolysis route, the other route is also there, that is waste to hydrogen. See, biomass gasification is there, then even we can target a lot of waste is being generated across the cities, so that also can be targeted, and a lot of work is going on in oil sector also. Like my previous organization, we have initiated work with the Indian Institute of Science on biomass oxy-gasification to produce hydrogen. That project is also progressing well. So these are, see, both, I think, electrolysis as well as biomass gasification will be a very good route for India, because we are an agrarian country and we'll have to focus on biomass also in this direction, in this area. And see, as far as electrolysis is concerned, see, there is a big challenge, like the electrolyzers demand is increasing, and the other major challenge is the water requirement for the electrolyzers. That is going to be a big challenge for India, especially India. And then, see, as far as green hydrogen mapping is concerned, there is a potential, like we can replace crude oil. We are importing a lot of crude oil. We are importing a lot of natural gas. We are importing a lot of coal. We are also importing ammonia. So refineries have made plans to set up, already refineries have made a plans to set up 130,000 tons per annum of hydrogen by 2030. So these projects are in advanced stage now, and so we will see some of the electrolyzers coming up in one or two refineries by 2024-25 also. So they are trying to replace the blue hydrogen with the green hydrogen. See, as far as electrolysis is concerned, there are three technologies, especially like PEM electrolysis, alkaline, and then new technology which is coming up, like solid oxide electrolysis, which is high temperature electrolysis. This, of course, a lot of work is going on in this SOEC because, see, in the conventional electrolysis, the power consumption is very high, see, up to 4.5 units per nm cube. So it's about, roughly we say that 50 units per kg of hydrogen. But this SOEC, the total requirement of power for per kg is about only 32 units. So that can bring down a lot of hydrogen cost, production cost. Now coming to this hydrogen cost, I've just tried to put down like the cost from the various paths. As you can see, gasification, coal or biomass, the current cost comes about 200 to 220 rupees, or roughly about $3. Biomethanation, of course, for the CBG, we can use that for production of hydrogen. And you can see that, again, here the cost is about $3 to $4 roughly. Reformers, of course, are the cheapest. Then solar electrolysis, at present, the costs are about not less than $6 to $7. So a lot of work is going on to bring down the cost. But ultimately, the two major things, like one is the solar, the renewable energy cost, and the second is the electrolyzers cost have to come down. And methanol reforming and photochemical water splitting, of course, is a long route. See, this is one of the initiatives which has been taken up by my previous organization. I was involved in this, and we have initiated a complete project, like it covers all the facets of hydrogen. Like you can see the biomass production, which is there from 4 different routes. Like biomass gasifier is being set up, solar electrolyzer, all the 3 types of electrolyzers are being set up. Natural gas reformer will be set up there, and biomethanation, like reforming of biomethanation, which will be done in the reformer only. So these all 4 routes are being tackled together in a single place. And then we are also working on hydrogen, like hydrogen storage. We are working on the type 3, type 4 cylinders. And dispensers are being set up for 350 bar hydrogen dispensing. And bus, of course, fuel cell development is also being done, indigenous fuel cell development, for which 15 fuel cell buses will be running under this project. Now coming to hydrogen storage, see, I feel that for a hydrogen economy to come, especially for the power sector, hydrogen storage will be a big challenge. And like already there are, like in Japan, you can see, we know that they are already using hydrogen in transport sector, and Mirai uses a 700 bar hydrogen storage tanks, type 3 type storage tanks. And a lot of work is going on in the cylinder side for India also, like then metal-based storage of hydrogen and like organic frameworks. So these are the new things which are coming up, but there are a lot of challenges, as the current hydrogen storage is not more than 3 to 4% is what people have achieved. And we have to go to more than 5.5 to 6% of hydrogen storage. Then coming to like one of the things which I say that for hydrogen economy to come, and especially for we have to transport hydrogen through pipelines rather than taking in the trucks and trailers. Though, of course, they are also one of the media, but I feel that hydrogen through pipelines will be a very good option, and a lot of work is going on. And actually, I'm also convening one of the ISO international standard, and I'm the convener for that. And we are now working on how much of hydrogen can be blended in the existing natural gas pipelines. So that is a big thing going on, and about in a year will come out with the mandate that maybe we are working on that. We are trying to have maybe up to 15% of hydrogen can be transported through natural gas lines existing. And now coming to fuel cell, of course, I know that most of you know that and somebody told also about the Mirai. So you can see the average 150 kilometers per kg of hydrogen. So these type of averages people are getting in one fill of hydrogen of 5 kg. We can go about 1,000 kilometers. So that's a very big achievement by Toyota, and Honda also are working, and many automotive companies are working on the fuel cell. But I think for India on the transport, first hydrogen will have to come in the refineries or fertilizer industry, and then we can slowly approach to the transport sector. Because see, what I feel that at this stage, hydrogen for the captive use is a very good option, and the cost will be cheaper. But once you have to transport hydrogen, that takes a lot of issues are there, mainly in the cost side. See, I can just give you an example. We produce hydrogen in our refineries at about say $2 to $3, and then I was at Indian Oil R&D, and we used to pay about $10 to $12, 800 to 1,000 rupees a kg for a hydrogen cylinder. So you can see challenges are there in the transportation and other things. A lot of initiatives have been taken up by Reliance, of course, GAIL, BPCL, IOCL, NTPC. All these are towards green hydrogen. L&T, Adani, HPCL. So all have taken a lot of initiatives in the area of hydrogen, green hydrogen especially. And now I will conclude with basically the challenges which are there. So the first challenge is on the production side is to bring down the cost to $1 per kg. Very optimistic, I think, we will see. And development of SOEC, I feel that this can be a game changer. Then high pressure electrolysis, of course. Electrolysis of saline water. So I told you that water will be a big challenge in production of green hydrogen. So saline water electrolysis, if we are able to crack that, so that can be a very good option and will take hydrogen economy forward. Syngas production, of course. Then transporting hydrogen through CNG pipeline. This, of course, initially I told you. Then high pressure cylinders for storage. We have to develop our own indigenous cylinders for transport application, especially for the transport application. Then material-based hydrogen. If this is cracked, again, this will be a big game changer, because you can store a lot of material once you have a lot of hydrogen in the material-based hydrogen storage option. Then underground storage, liquefaction, of course, it's well developed in US. So for maybe a country like India, we'll have to see, because of the temperature and other things about boil-off losses and other things. And HRS, again, in the transport sector, if it has to come, then who will put the station first, or and who will bring the transport vehicles first? There is a chicken and egg problem there also. Hydrogen in the IC engines, this was initially what we did in Indian Oil, but so now again it is picking up. A lot of people are trying to use hydrogen in IC engines and turbines, and this is also one of the area which is picking up. And fuel cell-based application, of course, is there. And then electrofuels, again, this will target, of course, CO2 along with green hydrogen. We can produce, again, the fuels. So this is also being worked upon. And I think that's all from my side. Thank you very much.
Thank you, sir, for the insights. Next up, we have Mr. Kapil Maheshwari, Leader Renewable Energy and Green Hydrogen Ecosystem Development, President, Reliance Industries Limited.
Good evening, everyone. Thanks NSFI and Informa Markets to invite me here. And possibly after so many August gathering and speakers have spoken, there's a little left, but I would still try and bring on my perspective to that. First, what Mr. Malhotra said, color doesn't matter. Having worked in renewable field for 20 years, I would say color does matter. And that's the reason you have also put the title of the conference as green hydrogen and not hydrogen. So it does matter. We are having these conferences and multiple sessions for last 2 years because color does matter. And in next 10 years, we are saying as country, we are going to double the hydrogen production because color does matter. Otherwise, in last 10 years, we were not able to. So as in country, we possibly are at around 6 million metric tons of an hydrogen market right now. When we say by 2030, we'll be 12 to 15, it is because we are talking green hydrogen. It is not because we continue to produce and consume gray hydrogen. So a little perspective, but at the same time, I strongly agree with him that we really need to develop storage and transportation aspect of it, which is what we call it as in the overall value chain as the midstream side of it. So we are discussing possibly a good amount of discussion on the hydrogen is happening on the upstream, where we are talking about production of green hydrogen. So, we have been talking of opportunities and challenges in electrolysis process. We have been talking of good amount of discussion on the downstream as well, which is on how industry can use it as feedstock or fuel, or how transportation of long-haul vehicle can happen with this. But possibly one holy grail area is the storage and transportation. And that is where I think we can certainly start the work if we haven't. We do understand there are challenges, as in country, but we are able to manage, at the same time, he correctly mentioned that it is colorless, it is odorless. We know how to handle hydrogen. We have been producing it and consuming it. So all the safety challenges, etc., are known as in country to us, and possibly we know how to handle even that. The second aspect I would like to add is possibly this is the first time we are seeing in any new energy or renewable energy sector that it has given, as in country, an opportunity to us to not follow and possibly lead. So if we've spoken, on renewables, how, we have seen the journey overall, but we've always been an follower in this whole thing, be it we have technology adoption from Germany or China, or be it downstream application in PV power projects as well. But this is the time where possibly everyone else also is on the same stage, and everyone else also is in the same situation and circumstances where we are. So this gives us an opportunity, possibility to lead right now. The third aspect, what I would cover possibly would be on the manufacturing side, that we do have some good policies. The February hydrogen policy do provide some incentive on, particularly on ISTS waiver, and providing single vendor clearances, providing land at the ports for creating bunkers, etc. for this. At the same time, where it is still silent on, and which is where the draft mission is awaited, is we understand that all of this is true, but electricity does remain a concurrent subject between the center and the state. So we really need to figure out how do we, when we say ISTS waiver and banking for 1 month, how do we address this within different states in India? The second aspect I would say was the policy was silent on. It was on the demand creation, and the fellow panelists just spoke on GHCO, which is the green hydrogen compliance obligation, as to what it will be for different sectors in fertilizers or refineries or natural gas, and what percentage the emission would come out to be. But everyone believes that this kind of an overall thing would definitely give us what we target as a nation to minimum do 5 million metric tons of green hydrogen by 2030. Now, just to give you a perspective of when we talk 5 MMTPA, what it calls from, possibly an installation of solar if we are doing electrolysis process through renewable, and possibly the requirement of water, what was also touched. So I would say we are positioned much better compared to some of those other nations. 5 million metric tons is roughly around 115 to 120 gigawatts of renewable power. Imagine the land to do it is nearly around 4 to 5 lakh acre of land. This is, a couple of states put together here in India. So the kind of civil infrastructure we would require for that. It requires nearly 50 billion liters of DO water, which can be used in the electrolysis process. But I would still say that we are positioned better. Reason is we do have at least access to seawater. There are nations who are talking about large hydrogen policies, but they don't have even access to water, be it in any form or shape. At least we have seawater available. We can think of SWRO and other techniques to figure out how do we provide the pure water for hydrogen electrolysis. The other aspect I would touch is where do we lead from? We lead from a couple of aspects, which is the most beneficial thing for us as a country is that compared to places where they have put a lot of policies for both domestic and imports. So take an example, Europe has come up with a policy of 20 MMTPA, where 10 would be from EU region and 10 they want to import it from other region. Where we are positioned very, very well is that we have the land to put renewable. We have the resources like sun and wind, which is abundantly available, and good sunshine. So our yield is much higher, specific yield, compared to any other place. We have the manpower and talent and skill set available in the country. For whatever said and done, these 10, 12 years of solar project installation has given us the right set of skill set by which we can cover the 50-60% of aspect which was spoken about, which is the renewable energy going in the overall thing. Then I'll touch upon what us at Reliance Industry are trying to do is possibly looking at all of this in a little more holistic way. So what we are trying to address is possibly every single element which would go in this. So when we talk of upstream, it is the production of renewable energy. So we are coming up possibly with polysilicon to and solar module, a complete vertically integrated value chain on that. We're coming up with another gigafactory for production of electrolyzer, another gigafactory for production of battery storage, because we certainly need round-the-clock power for renewable for electrolysis compared to its intermittent nature. And the fourth gigafactory would be for fuel cell. So this covers possibly almost on all the critical elements of it. Also looking at storage and transportation, we really need to address whether it will be, and small elements around it. We've been speaking a lot on production of electrolyzers within the country. We already have almost 50% of the overall thing. When you talk of the electrolysis process, the stack, which is the technology, along with the anode and cathode, is nearly 50 to 60% of the overall thing. 40 to 50% is still the balance of plant, where we have all the other things which are available in India, from rectifier to transformers to walls to pipes to storage cylinders, every possible thing which could go. So this exists. What we need to do now is possibly take it to the next step and then add more to the local value addition. Government of India is looking at something similar, PLI, what it has come for solar modules, as well as the advanced cell chemistry now coming for electrolyzers as well. So that will be an interesting aspect. We look at it. There are small elements which we really need to look. When we talk of a high pressure in terms of putting carbon fiber cylinders, and I want to pressurize because it's very light, and put it to 700 bars. Where are the compressors? We don't have any manufacturing for such high pressure compressors. Whatever we have is typically a normal compression, 27 to 30 bars kind of a thing, which is where most of the alkaline electrolyzers also would operate at. So these are elements of also which we can look from the whole manufacturing and the value chain. And this also provide an opportunity to a lot of other ancillary infrastructure to be built, from MSME to mid-sized industries also, who could work on various elements, especially on the midstream side, which is what I would say in the storage and transportation. And with that, I would say these are some of the thoughts I would like to share. Thank you so much for your time.
Some very important and pertinent thoughts, including how green hydrogen is creating level playing field in the space of renewable energy. Thanks for your thoughts, sir. Next up, we have Mr. Arnava Sinha, Vice President, GreenKo Group. Let's have a huge round of applause for him, please.
Respected Pranab Mehta ji and NSCFI, my esteemed panelists and members of audience. It's an honor to be here. Good evening to you all. I think a lot has already been spoken. There's very little for me to speak anymore, so I'll just keep it brief. I don't think there is anybody out there today who still questions climate change. I hope not anyway. And since the beginning of the year, the whole world has been in a full-blown energy crisis. In some ways, and in a very matter-of-factly speaking, I think the world is now realizing what India has been facing for the last 50 years. So if we don't talk about moving away from the fossil fuel industry to a more sustainable form now, then we probably would never do it. Now, how we are going to do it? Of course, we can debate on that, we can deliberate on that, and that has been going on for a very long time. I will not delve into that. What I will do today is I will just take you through a little bit of what the GreenKo Group has been doing over the last couple of years or so. So we do believe, and we are absolutely convinced, that green hydrogen, that transition to green hydrogen has to happen, will happen, irrespective of whether we like it or not, irrespective of whether we are a part of that or not. So we are going ahead and doing our bit anyway. And we do believe also that green ammonia is a very good vector when we are moving toward this hydrogen economy. So some of the things that we are doing at the GreenKo group, we are setting up a 300 ton per day green ammonia plant in Himachal Pradesh. We've already made announcements of a 1 million ton per annum green ammonia plant in the East Coast. And we are very privileged that one of the biggest names in India, ONGC, has actually decided to partner with us to set up another 1 million ton per annum green ammonia plant in one of the two coasts of India. Now, is this just wishful thinking, or are these just announcements, or do we have some concrete plan of action to back ourselves up, right? So what gives us the confidence that these projects will see the light of the day? So if we talk about the value chain, which all the panel members have already talked about, but I'll just touch upon a couple of things here. Obviously, raw material comes into mind. And when it comes to production of green hydrogen, the raw material is power. Renewable power, to be specific. We all know about the intermittency issues of renewable power. So more than the cost, it's actually the availability of power that we are talking about here. Of course, the cost is the other element that we'll have to be careful about. So what we have done ourselves is that we're trying to protect that availability of power, and we're trying to do that through round-the-clock pumped hydro storage projects, which will give us firm, on-demand, round-the-clock renewable power through our pumped hydro storage projects, the first of which is coming up in Andhra Pradesh sometime this year, or sometime next year around this time. Hopefully, if we have this conference next year, we'll be in a position to give you a glimpse of how that project looks like after commissioning, right? The second thing that is important in the equation of raw materials is actually the electrolyzer. Again, we can debate about what electrolyzer system is the right one. We can debate about whether the alkaline system is the right one, whether PEM is better, or should we wait for SOEC to develop, which may still take a few years, mind it. Right? So what we are doing is we are going ahead and indigenizing production of electrolyzer in India. So what we have done is we have formed a joint venture with John Cockerell of Belgium, one of the largest electrolyzer manufacturers in the world, and we are putting up a 2 gigawatt factory in India, which is getting started actually in the next couple of months. Right? The commissioning will happen, of course, a little later, but the factory is going on the floor next month or so. So having got access to round-the-clock power, having got access to electrolyzers, because mind it, the world has only, in 2021, if I talk about the figures in 2021, the total amount of electrolyzers that were sold in the world is less than 500 megawatts globally. And we are talking about gigawatt capacity starting from next year. Where is it going to come from? Where will be India as a country in that pecking order? Are we going to be at the forefront? Are we going to get everything that we have asked for? Or are we going to be in a position where we will have to develop our own? We do think that we will have to develop our own whether we like it or not. We may not even have a choice. That's what we are doing. We are setting it up. Now, the two combined would give us that opportunity, would give us that entry into making green hydrogen in the cheapest possible way. Beyond that, the ecosystem still has to be developed, and no one organization can do that. And in fact, I would go to the extent of saying that we should not even wish for a single or a handful of organizations to be able to do everything. We all know what happens when you create behemoths. We don't have to look further. Just look at the fossil fuel industry, of which I was a part of for almost 2 decades. So it's an opportunity for us, you know, as a country, as a human race, to move into something more tangible, more sustainable, and at GreenKo we are doing the part. Now, having said that, there are still certain areas that will need to be looked at. For example, economy. And that is the first thing, right? I mean, whatever we make, we'll still have to make sense. The business itself needs to be sustainable. Whether it's from a profitability point of view, cash flow point of view, you name it. And for that today, as for any other industry, there needs to be certain probably concessions, waivers, exceptions, incentives that will have to be provided by the government. We do expect that, and we really hope that the detailed document of the green hydrogen mission will be released very soon, and we're waiting for that. We have been waiting for that now, quite eagerly. And once that gets rolled out, we do believe that there will be a renewed vigor and there will be much more traction and action that we will see. But again, I urge you all, and in this community particularly, that we should not even have to wait for that. Things will happen. We should continue on our path of making it happen, right? And with that, I think I'll be brief, and that's all. Thank you. Thanks a lot, and thanks for having me.
Brief yet very insightful. He just pointed out the power of collective. Let's have a collective round of applause for the same. And next up, to impart academic perspective to this conversation, may I invite Professor Rajneesh Kumar. He's from BITS Pilani.
So, thank you, Mehta sir, for inviting me. So, I will give a quick brief of what we are doing at BITS Pilani. So, since all our speakers are from industry, they have given all the data and overall view. So, I will quickly go to some insight of the overall green hydrogen generation. So, we start with the solar panel. So, one of our previous panelists said that we'll have to provide very cheap power. So I hope all of you will be surprised to know that we do have enough solar pumps remaining idle. So we can get power from there without investing any money. So that's why our first part is this solar panel. So we do not have to invest so much money on this solar panel. They are already existing in a large number, and they are remaining idle for a very long time. Or if they are used, they are not used through entire day. So we can at least get 5 to 6 hours from these solar panels. And of course, they are around 3 to 4 kilowatts peak generation. So that solves our big problem of power for, power for green hydrogen generation. But what is interesting is we forget about the interface between those solar panels and electrolyzers. And they are the backbone of all these green hydrogen generation, and that is DC to DC converter. So nowadays what we are doing is we are taking power from utility, converting it to DC, and then providing it to electrolyzers. So what we are proposing here is, and of course we have done some experiments to showcase our research here. So what we do is, depending upon the voltage rating of the solar panel, we make dedicated converters for a given specific electrolyzer. So that is our first part from power electronics point of view. And as we know, these converters are very, very easy to make, and they are very cost effective, because all the devices, etc., are well known to us, and converter technology is well developed. But as far as this electrolyzers are concerned, we are still struggling to find out suitable DC to DC converter to interface with these solar panels. And then second part is, as you can easily see, this is the lab model. So what we did was, we made electrodes from carbon cloths doped with some nanomaterials to provide or to generate hydrogen. So we are able to generate hydrogen with some novel converters, and these hydrogens are very, very pure. That we have already published. And after that, suppose we are generating hydrogen at very remote plant. So we need some kind of IoT to measure the data, and if possible, take the corrective measures. So this is the overall view of what we are doing at BITS Pilani from technical point of view. So what we are looking at few industry people to fund us so that our technology, which seems very alien to us, can become indigenous to us. So since I came late, I was not able to meet some of you, but since many of you are here, I would like to interact and then try to find the possibility of carry forward this research if you find it interesting. So this is very short presentation, and thank you all. If you have any special query, I would like to answer. Thank you.
Let's have a huge round of applause, first of all, for all the speakers here. And the topic has been covered from various perspectives to do justice to what has been a fast emerging area. So thanks a lot to all the speakers. Let's have them pose for a group picture. And the discussions can, of course, continue. The speakers would be available personally to be contacted as well.
Speakers, I would like to say just one thing. I started to advocate for solar energy 20 years ago, yes? And imagine 20 years ago, solar was 3,000 times smaller than today. And we grew the solar industry only with our resources. With the green hydrogen, the situation is a bit different because we have big players who are interested in the business. We have also billions, even hundreds of billions potential financing which will come. So I think there is a very important, you can see on our picture, together we are stronger. The most important element now is to unite leaders from the hydrogen with the leaders from renewable energies, and also to make awareness amongst decision makers. And together will be able to grow the hydrogen even quicker than in the past. So I see everybody is so busy, so just very shortly, in Cleantech Business Club, we created Green Hydrogen Hub. So we will invite around 30 to 50 leaders around the world, and together we'll be working on the global roadmap for the hydrogen. So I think I can finish already right now because everybody is leaving. So I would like to thank to Mr. Pranav Mehta. I would like to thank to Renewable Energy India for this great opportunity. And as you see, together we are stronger. Green hydrogen and renewables are the best friends forever. Thank you very much.